Good morning. Today we will see the chemical shift equivalence of protons replacement test. It is for homotopic, enantiotopic and diastereotopic protons. First of all, we will see the homotopic hydrogen atoms. For this we consider isobutylene as an example. Here the protons which is attached to third carbon atom and we replace one by one. So uh, first of all, when we consider first example where Z is replaced, hydrogen is replaced by Z, and in second also hydrogen is replaced by Z. But the first example and second example after replacement of Z are the same, and such type of proton is called as homotopic hydrogen atoms. Then second one is enantiotopic hydrogen atoms. We consider the example ethyl benzene, whether there are different protons are present here, and we consider the enantiotopic hydrogen atom B for B, and we replace the HB and HB by the G group, and we got two structures, that is A and B, and this A and B are having the relationship. They are non-superimposable when we put the mirror in between this, and hence they are enantiomers. So such type of protons is called as enantiotopic hydrogen atom. And third one, diastereotopic hydrogen atom. We consider the example vinyl chloride, whether the there are three types of proton, Ha, Hb and Hc, and we consider this test for Hb and Hc, whether we replace Hb by Z and Hc by Z. When we replace the Hb by Z, we got the cis structure, and when we replace the Hc by Z group, we got the trans example. So the relation in between cis and trans, that is a geometrical isomerism, and hence they are diastereomers, and such type of protons is called as diastereotopic hydrogen. Okay friends, after the discussion of homotopic protons, enantiotopic protons and diastereotopic protons, we will see the different types of coupling and their notation. Now there are three types of coupling: vicinal coupling, geminal coupling and long range coupling. Now we take example one by one. Now vicinal coupling, this is the coupling in between two adjacent protons. Suppose here different groups are attached, so in this structure one hydrogen shows different signal and another hydrogen shows different signal because they are not chemical equivalent, and hence they shows different signals. Now the coupling in between these protons are called as vicinal coupling. Actually, we already discussed about this vicinal coupling in TYBSc as well as MSc first year classes. But today we will see the notation regarding this, because notation is very important in non-first order spectra. Now here, when we consider the notation regarding this, there are coupling constant. This term is important here, and this is noted by capital J. And this vicinal coupling is 3 bond coupling. 3 bond coupling. 3 bond coupling. And that's why this is called as 3J. This is called as 3J. Why it is called as 3J? I highlighted here 3 bonds. This is first bond, this is second bond, and this is third bond. Means the distance in between these coupling partners or coupling proton is 3 bond. So that's why such type of coupling is noted by 3J. And the coupling in between two protons, and here we write down HA and HB. So you must notate, or you should know, the notation of vicinal coupling 3J HA HB. Clear? Now we take second type, that is geminal coupling. Geminal coupling. Geminal coupling is nothing but those protons are attached to same carbon atom. Attached to same carbon atom. Now here these two protons having the different chemical environment due to the planarity of sp2 hybridized carbon atom HA and HB. This is called as geminal coupling. And geminal coupling, again we will see the system notation J, and these two protons are away from two bonds. That's why it is called as 2J. It is called as 2J, or it is also called as 2 bond coupling. 2 bond coupling. 2 bond coupling. And here the coupling in between HA and HB, geminal coupling. And this geminal coupling is rarely observed in the compound. Then next one, long range coupling. Long range coupling. Okay, long range coupling. Now this long range coupling, we take example of aromatic compound, and here suppose H, here H, and here also H, but here suppose Cl, here Cn, here OH group is attached. So these three protons are different chemical environment. So this compound shows three signals. Now long range coupling is nothing but the coupling more than 3G, coupling more than 3G. Now suppose you consider the coupling in between EHA and EHB, and why it is called as long range we will see here. The bond distance is 1, 2, 3 and 4. That's why this is called as 4J, and this is the coupling in between HA and HB. Such type of coupling is called as long range coupling, and in another way it is also called as 4 bond coupling, or it is also called as meta coupling. It is also called as meta coupling. In this case, ortho coupling is the example of vicinal coupling, but meta coupling and para coupling are the examples of long range coupling. Now suppose you consider the coupling in between HA and HC, coupling in between HA and HC. Now what is the system notation here? See, 1, 2, 3, 4 and 5. So here we will write down 5 here, and here HA is coupled with HC. So we will again remind there are three types of coupling. Vicinal coupling is frequently observed in the compound, and the notation is 3J. Why it is 3J? Because these coupling partner protons are away from 3 bond. So vicinal coupling is 3J coupling. Then geminal coupling. Here the coupling protons are attached to same carbon atom but having the different chemical environment, and here this is system notation is that 2 2J. Why 2J? Because these coupling partner protons are away from two bonds, so it is called as 2J. And next one, last one, this is long range coupling. Long range coupling is observed very rarely in the organic compound, but we take here one example, and popular examples are from the aromatic compounds. And here, when we consider the coupling in between HA and HC, this is the example of long range coupling, and it is noted by 5 bond coupling, because this HA and HC are away from 5 bonds. Now actually here these 3 examples are the coupling in between hydrogen, proton and proton. So such type of coupling is called homoatomic coupling. But in case of CMR, there are coupling in between 13C and H1, and such type of coupling is under the heading heteroatomic coupling, and the notation is that Z, and there are only one bond in between 13C and H1, so this is called as 1J. It is noted by 1J, and here we write down 13C and H1. So 1J is observed in one and only in CMR, not in PMR. The above all examples from the PMR. This is the basic difference between PMR and CMR. So what is the summary of today's lecture is that we discussed 1J, but in between 13C and H1. Also we discuss about the 2J, HH, H1, 3J in between H1 and H1, and 4 or more in between H1 and H1. Now here this is the system notation for different couplings with their coupling constant, and here first one is from CMR and remaining are from H1 NMR, or another name is PMR, and 2J is Gemini coupling. This is the system notation for Gemini couplings with their coupling 3J constant. Is vicinal coupling, and here first one is, and 4J is from CMR long range, and remaining are coupling from H1 NMR or another name is PMR. And 2J 2J is geminal coupling. 3J is vicinal coupling, and 4J is long range coupling. Thanks. We will stop here.